All right, section 7.4, using substitution as a strategy to solve linear systems. Okay, so last day we did linear systems and you learned how to do them by graphing. A little bit tedious, not so nice. So today I want to show you an algebraic method of doing the same thing. Okay, solving for the system equation, finding x and y in the system. But before we do that, let's just go back and do some prerequisites. Let's see if you can just solve for x with the following examples here. Solve for x meaning isolate x. So really I want x by itself on the left-hand side. So you probably want to move the 6y to the right-hand side. And to do that, of course, you're going to subtract 6y. And that's it. Very straightforward. For part B, however, you got 3x. So the first step is the same. I'll go 8 minus 2y. But now you need to get rid of that 3 in front of the x. You can do that by dividing every single term by 3. And there you go. There's your answer. Doing the same thing with y in the next examples, I'll just say y equals to 11 plus 4x. Okay. And then this one, once again, a little bit more tricky. We'll do the same thing by minusing 3x on both sides. Now I'm going to ask you to divide every single term by negative 2, because you want to get rid of that negative 2. 8 divided by negative 2 is negative 4, and this is 3 over 2x. So there you go. There is your answer for y. So we're going to use this idea to try to solve the system of equations using algebra. So you've seen systems like this one, example number 1. What I want to do now is show you how we can use these algebraic techniques to determine an exact solution. So one of these methods is called substitution. That's what we're doing today. That's spelled wrong, right? S-T-U-T-I-O-N. Substitution. In this section, variables will be eliminated by solving one equation for one of the variables. Okay? Sometimes we call it isolating the variable. That's what we just did in our prerequisites. Then you're going to substitute it into the other equation. So let me show you what I mean. What I like to do first of all is label my equations, number 1 and number 2. It just makes it easier for us to describe them. I'm going to show you two ways to do the exact same question. Okay, so the column to the left is one method, and a column to the right is just another one. Both methods require you to isolate one of the variables first, but you have a choice. So taking a look at the column on the left, what we want to do is choose to isolate x first. And if I ask you to choose to isolate x, which equation do you think is the best one for me to use to isolate x? And if you said, let's use equation number 2, I'd agree. Because equation number 2 already has x by itself without a number in front. So what I have now is x equals to negative 7 minus 2y, right? Take the negative 2y, or positive 2y, bring it to the left side, make it negative 2y. Now, what they're going to ask you to do is substitute the above expression, and I'm going to call this now equation number 3. So let's substitute equation number 3 into the other equation. So the other equation that I haven't used yet is number 1. And here we go. So 4x. Now notice wherever I see x now in this case, I'm going to replace with a big bracket. And what's going to go inside my big bracket is what I just had from above. So that's the negative 7 minus 2y, right? Because that's what's equal to x. Go ahead now and distribute. So negative 28 minus 8y minus y equals to 8. I'll ask you now to just collect like terms. Guess I'll add 28 to both sides. Negative 9y equals to 36. Divide everything by negative 9, so y equals to negative 4. There you go. So now you solve for y. But wait, we're not done yet. We've got to solve for the other variable. So now what we're going to have to do is find out what x is going to be equal to. Now, which equation do you think I should use to find out x? Should I use number 1, number 2, or number 3? Well, technically, you can use all three. It doesn't make a difference. As long as you do your algebra correctly, it's not a big deal. But one of these equations is actually much easier than the others. And if you chose number 3, you are correct. Because number 3 already has x by itself. So why don't we just go ahead now and plug in the value of y, which we found from before, which is negative 4, and then we'll solve for x. Oh yeah, that equals to 1. Okay? And ultimately then, your final solution for this system of equation is we'll write it in terms of an ordered pair with x being first and y being next. There you go. Now let's see if you can do the same thing with the same equations, but this time let's choose to isolate y first. And if I ask you to isolate y, which equation do you think you should use? If you said let's use number 1, that's correct. So I'm going to have negative y equals to 8 minus 4x. I'm going to ask you to solve for y, so I'm going to divide everything by negative 1, so that's negative 8 plus 4x. Great. Once again, you're going to have to substitute this. I'm going to call this equation number 4. So let's substitute equation number 4 into the other equation that we haven't used. And since we used 1, the one we haven't used is 2. Go ahead now, so x plus 2, and in this case, wherever I see y, I put that big bracket in, because that gets replaced with negative 8 plus 4x. Okay, go ahead now and distribute and simplify. So x minus 16 plus 8x equals negative 7. How about 9x? 9x minus 16 equals to negative 7. We'll add 16 to both sides, that's 9, and you get x equals to 1. And of course, this is a system, so we'll need to solve for the variables. So I'll use equation number 4. Y equals to negative 8 plus 4 times 1. That's negative 8 plus 4. And of course, that equals to negative 4. So in the end, my solution is once again, x is 1, y is negative 4. Doesn't matter if you solve for x or solve for y. Both ways gives you the same answer. And that's what I said down there. Okay. Turn the page. And now I'm going to say to you, well, even though it doesn't matter which variable you isolate, sometimes one is easier than the other. Okay. So I'm going to do 2a with you, and then after that, hopefully you can do b and the rest. I'm going to ask you for 2a, which letter or variable do you think you should solve for, x or y? And if you answered y, I'd say correct, because it's a little bit easier. So I'm going to use equation number 2, and I'm going to ask you to solve for y, or isolate y. So y equals to 8 minus 2x. I'm going to call this now equation number 3. So now what can I do with equation number 3? Well, now you want to substitute equation number 3 into the other equation you haven't used. That would be number 1. And let's see what happens. 5x plus 3, and wherever you see y, let's put a big bracket now. And I'm going to dump what I had there for y into the bracket. And you see how this is nice now? Because now we have not a system of 2 equations with 2 variables, but we have 1 equation with 1 variable. Good old grade 8 and 9 algebra. So 5x plus 24 minus 6x equals to 5. 5x minus 6x is negative x, plus 24 equals to 5. Negative x equals to negative 19, so x equals to a positive 19. Don't forget you're still not done yet, because you need to now solve for the other variable. So now let's solve for y. And we're going to use equation number 3 to do that. So y equals 2, and number 3 is just up top here. 8, take away 2, and wherever you see x, replace it with 19. 8 minus 38, how about negative 30? So y equals to negative 30. And please write your solution as an ordered pair. So all this work, and I'll say the solution here is x is 19, y is negative 30. Ta-da. All right. This is the general idea of substitution. So now you should be able to do the rest. Okay, B, C, and D. I will do it too, but if you're listening online, stop the video and work on them on your own. Then come back and double check your answer. Don't be afraid of fractions. Okay, if you're trying C, this one's a little more tricky. You have to decide which one you want to solve for, and they both look pretty nasty. So it's up to you, okay? I'm going to solve for x. I'm going to use number 1 and solve for x. By the way, if you don't like fractions, you can use decimals. Not a big deal, okay? Steps are the same for all these, so hopefully that's not too difficult. I'm going to change this one to a decimal just for those of you who like decimals. That's 12.5y minus 2y equals to 29. And that's actually 14.5y equals to 29. And that actually equals to a nice number, y equals to -2. So once again, if you don't like fractions, decimals are perfectly fine. Don't forget, though, to now go back and solve for x. I'll use equation number 3. There you go. Okay. All right. D. Also not so nice. You decide what you want to do. I'm going to take equation number 2 and solve for y. Okay, now notice here we're going to get some nasty fractions. I see 8x. Oh, those are not too bad, I guess. 4 times 7 is 28. 28 minus or divided by 2 is 14, is it? Yeah, so that's negative 14x equals to 1. Negative 6x equals to 1. Not too bad. Okay. And then, of course, you want to find y. So now find y by using equation number 3. So y equals to negative 7 over 2 times negative 1 over 6. And that's just positive 7 over 12. So don't freak out when your answers are fractions. That's perfectly fine. Your solution in this case is x is negative 1/6. Y is 7/12. And once again, if I'm going too fast, just stop the video and rewind. Stop whenever you need to. Okay? Work at your own pace. That's what you can do. Okay. Let's do some more. Next page. These get more interesting. All right. Well, same kind of strategy. So I'm going to label the equations 1 and 2. I'm going to ask you perhaps to solve for x. So I'll say using number 1, let's solve for x. Because it looks like it's pretty easy to solve for x. You get 24 plus 8y. And then of course we're going to call this equation number 3, and we're going to substitute now number 3 into the other equation, into number 2. Here we go, 2 brackets minus 16y equals to 30. Inside this bracket is 24 plus 8y. We're going to now distribute this, 48 plus 16y minus 16y equals to 30. And then you get 48 equals to 30 because the 16y minus 16y equals 0. Can 48 ever be equal to 30? This is not true. So what does that mean? So therefore there's no solution, okay, to this actual equation. Now if you think about this, and if you were to graph it out from last time, the no solution graph is a graph, recall, no solution from 2 days ago when we did the graphing stuff, means that the two lines are parallel and never meet. Okay. So in this example, when you have a left side number not equaling to the right side number, there's no solution. Okay. Visually graph, remember, it's like they never touch. Okay, so this is how you show the no solution answer algebraically. Let's do now part F. Same idea. We're going to rewrite these as 1 and 2. You decide what you want to do. I'll say let's use number 1, and once again, shall we solve for x or y? Let's solve for y this time, just to make things a little bit more spicy. Okay, once again, it doesn't matter if you solve for x or y, but I'll just do y. So negative 4y equals to 8 minus 6x. Going to divide everything by negative 4, so negative 2 plus 3 over 2x. Let's call this equation number 3. Take that now, let's substitute equation number 3 into number 2, and let's see what we get. 9x minus 6y equals to 12. Stick that into the y. Distribute 9x plus 12 minus 18 over 2 is 9x equals to 12. Now look what happens in this case. 12 equals to 12. This statement this time is actually true. So if it's true, that means your solution is not no solution, but it's everything works. It's infinitely many solutions. What it means is that the two equations are exactly the same. So remember from last time, that's the situation where you have a line, and then you have another line that goes right on top of it. It's actually the same line. They look different in the equation form, but when you graph it out, it's the same. So therefore, there are infinitely many solutions. And so this is how you demonstrate infinitely many solutions algebraically. The number on the left side equals the number on the right-hand side. Okay? Right, this last example here on this page is another system that you need to solve, but it has fractions. And in order to help you get rid of these fractions, what you can do is the following. You can rewrite these equations without fractions. Okay? So we can do that without actually changing the solution. So I'll put a little note here. Okay? So when dealing with fractions, we can, let's say, rewrite them. And I'll say this, by multiplying by the lowest common denominator. Okay. So the goal here is to rewrite the equations without fractions, but we don't want to change the actual value of the solution. Okay. And we can do this by just multiplying every single number or every single term of an equation by a number. So for example here, you don't need to write this down, but as an example, if I had 5x equals to, let's say, 15, we know the answer is 3. But if I were now to multiply everything by 2 to give 10x equals to 30, notice the value for x is still the same, right? So when you multiply both sides of an equation by the same number, you don't actually change the solution. So if you look at this here, I'm going to call this equation number 1 equation number 2. If you look at equation number 1, we have denominators of 2 and 3. So what do you think the lowest common denominator would be? And if you said 6, that's correct. So I'm going to take equation number 1 and multiply everything by 6. Now let's think what happens. It becomes 6a over 2 plus 6b over 3 equals to 1 times 6. Now we should be able to simplify this as well, because 6 divided by 2 gives us 3, so that's 3a. 6 divided by 3 gives you 2, that's 2b, and of course that equals to 6. Doing the same thing for the second equation, we can multiply everything by 12. So you get 12a over 4 plus 12 times 2, which is 24b over 3, equals to negative 1 times 12, which is negative 12. And once again, 3a plus 8b equals to negative 12. I'm going to call these now my new equations 3 and 4. And now I've written it in a form where it's just like everything else. So I'm going to ask you now to try to solve this on your own. Okay? I'm going to use equation 3. Let's say I'm going to solve for b. This is now equation number 5. I'm going to say sub 5 into, let's say, 4. Right, the rest of this is just the same as before, so I'm going a little bit fast probably for most of you. But once again, you can stop the tape if you need to. Cool. All right, last ones. All right, let's do the last part now, using substitution as a strategy to solve linear systems with word problems. So, in section 7.1, you learn how to actually represent situations with variables, and that's what you're going to have to do now. But after that, instead of solving by using graphing, you're going to now solve using this algebraic method of substitution. Okay? So here's the question. Janice, my good friend Janice, invested $2,000. Part of it is in something called a bond, and that's pretty safe, where you have a nice rate of return of 7% per year, meaning you get back 7% money. And the rest in the mutual fund, which is kind of like stocks and stocks and other things, where it's a little bit more risky, so there's a higher rate of return of 8% per year. Because after 1 year, the interest earned on the bond was $50 more than the interest earned on the mutual fund. So how much does she invest at each rate? So because they're asking you how much does she invest at each rate, I guess your two variables, if you like x and y, are x is the amount that is invested in the bond, right? Because there's two parts. So the other part would be, I guess, y, and that's the amount invested in the mutual fund. Of course, if you don't want to use x and y, maybe b and m or something like that to make life a little bit more interesting, that's perfectly fine. So once you've got your variables identified, let's see if you can come up with the two equations. It says she invested $2,000 in total. So maybe you're thinking, the two amounts added together should be 2,000. That's correct, and that's what this says. She invested 2,000 in total. Now the next one's a little bit more harder. It says after 1 year, the interest earned bond was $50 more than the interest earned on the mutual fund. So the interest earned on the bond, how do we describe that? Well, the amount invested in the bond is X, but the interest earned is a percentage, right? It's 7% of the amount. So 7% as a decimal is just 0.07. So 0.07x. Okay. So the interest earned on the bond, which is 0.07x, was $50 more than the interest earned on the mutual fund. Well, if Y is the amount in the mutual fund, what's the interest earned on the mutual fund? Right, it's 0.08. Now it says after 1 year, the interest earned on the bond was $50 more than the interest on the mutual fund. So if it says $50 more, where do I put this plus 50? Is it over here or over here? Which one? Okay, well, if you're not too sure, tell me which one's the bigger one. Which amount is more, bond or the mutual fund? And if you say the bond is more, that's correct. So this is the larger number. This is the smaller number. How do you compare larger with smaller? Where should we put the plus 50? That's right. Take the smaller number, add 50 to make it equal the larger. Congratulations, dear friends. Here's equation number 1, here's equation number 2. Now go ahead and solve. I'm going to use equation number 1, solve for y. Y equals to 2,000 minus x. Let's call this equation number 3, and let's now substitute equation number 3 into number 2. So this is the same kind of stuff as we did before, right? No big change. .08 times 2,000. What is that? Ugh, too tired. Use your calculator if you're not too sure, right? 2,000. I think it's 16. Oh, sorry, 160. Yeah, 160. Duh. 160 minus 0.08x plus 50 equals to 0.07x. Move by adding together, right? So how about 0.15x equals to 210. Go ahead and solve for x if you can by dividing both sides by 0.15. Yes, use your calculator. 210 divided by 0.15. That's $1,400. And then how about y? Well, of course, y would be 2,000 minus 1,400, which equals to 600. And so because this is a word problem, I want you to answer in a sentence. How much does she invest at each rate? Say something like this. Say something like Janice invested 1,400 in the bond and 600 in the mutual fund. Good. Right. So that's one type. Here's one more. Okay, we've done a question like this before, so I hope you can remind yourself how to do this one. I like to make a little chart going upstream and downstream. This is the one where it has speed, time, and then I guess distance. So, or distance, speed, time. So I'll say distance, speed, time, upstream, downstream. And let's see if we can fill in the information. Sue and Bill both paddled 20 kilometers upstream. Distance is 20 in 4 hours. The return trip is faster. It takes 3 hours. So that means they must travel the same distance. But the question is, what's the speed of the canoe and what's the speed of the current? So maybe I'll say this. X is the speed of the canoe. Y is the speed of the current. So remember upstream what happens? The speed of the boat and the speed of the current are in opposite directions. So how about this? X minus Y. And remember when you are going downstream, the two work together. So I believe the speed would be X plus Y. And remember also that we looked at that triangle, or in physics, you know, distance equals to speed times time. So note I'll say distance equals to speed times time. And with that knowledge, you should be able to come up with two equations. The equation going upstream would be distance 20 equals to speed x minus y times 4. And then downstream, distance equals to speed x plus y times 3. There's many ways you can do this one. Some of you probably ask yourselves to distribute, so that's fine if you want to do that. So equation number 1, equation number 2. If I were to distribute, you get 20 equals to 4x minus 4y. And then, of course, in this case, if I distribute here, you get 20 equals to 3x plus 3y. It's up to you what you want to do to solve this one. I'm going to take equation number 1, so let's use number 1, and I'm going to solve for, let's say, y. So 20, let's solve for x actually. Let's just mix it up. Solve for x. So 20 plus 4y equals to 4x. So once again, I just took this equation here, number 1. We'll divide everything by 4, so that's 5 plus y. So that's kind of nice. Because let's now use this. I'll call this equation number 3. And let's now sub 3 into 2. 20 equals to 3, and instead of having x, it's now 5 plus y plus 3y. Do some algebra. 20 equals to 15 plus 3y plus 3y. Okay, that simplifies to 20 equals to 15 plus 6y. Subtract 15 on both sides, so you get 5 equals 6y. And so y just equals to 5 over 6. And this is in kilometers per hour. And so therefore x must be the speed of the current. You can add that, and if you want to write this as a fraction, how about an improper fraction? That's 35 over 6. So to finish this off, I'll do this underneath. The speed of the current, sorry, not the current, of the canoe is the x value. So that's 35 over 6, and I guess this is kilometers per hour. And the speed of the current must be 5/6 of a kilometer per hour, which is, well, that makes sense, right? Water, pretty slow. There you have it, 7.4 in a nutshell, done.